Now the next method is method of integration. By part for definite integration. As we have already studied, the method of integration by part to obtain indefinite integral of product of two functions. We can also use integration by parts for definite integration. For getting the formula for definite integration, we have to find whether f(x), g of x, f dash of x, that is first derivative of x with respect to x, and g dash x are continuous on closed interval AB. Then a to b f of x g dash x dx is equal to f of x into g of x a to b minus a to b f dash x gx into dx. That is the formula for method of integration by parts for definite integration. In this we have just write the limit. There is range mentioned for the integration by parts as we done in indefinite integral. Now to understand this, we will do some problems in the next lecture. Now the first problem for method of integration by part is, that is number 1. Evaluate 1 to 0 to 1 x into tan inverse x dx. So first of all we will see by Lie method, inverse function is the first function, algebraic function is the second function. So let I is equal to 0 to 1 x into tan inverse x dx. So we will assume tan inverse x as first function and x as second function. So by the rule integration by parts, we will get first function as it is, differentiation of second function, limit 0 to 1 minus integration of derivative of first function into the integration of second function over the whole integration with limit 0 to 1. So we will put limit in the first part, that is 1 to 0. So it becomes tan inverse 1 into 1 by 2 minus tan inverse 0 into 0 by 2 minus 1 by 2 as it is, and in the integration, that is 0 to 1, ranging x square over 1 plus x square dx. So in the first part we get tan inverse 1 is pi by 4 into half, 0 into something is 0, and next, that is half, we will add and subtract 1 to get the same denominator, and we get half of 1 of, that is minus 1 minus minus plus 1. You are familiar with all these steps as we done so many types of integration in the previous chapter as well as in this chapter. So we will get this on adding and subtracting 1, and limit is ranging from 0 to 1 in both the integrals. So we get pi over 8 minus half 0 to 1 dx plus half, that is the formula of tan inverse x, that is ranging from 0 to 1. So we get pi over 8 minus half x, that is ranging from 0 to 1, plus half tan inverse 1 minus tan inverse 0. So we get here, that is, we get I is equal to pi over 8 minus half 1 minus 0 plus half tan inverse 1 is pi by 4 and tan inverse 0 is 0. So we get pi over 8 minus half plus pi over 8, that is 2 times pi over 8 minus half. So we get pi over 4 minus half. So this is the first problem in which we see that we make a trick, that is, we add and subtract 1 to make the integral easy. Now the next problem is evaluate integral 0 to 1 x dx 1 plus x square 2 plus x square. So in this, let I is equal to 0 to 1 x dx over 1 plus x square in the denominator into 2 plus x square in the denominator. So here if we see, again let x square is equal to t. So we get 2x dx is equal to dt. That means x dx is replaced by dt by 2. So here we will also change the limit. That is, here we are using substitution rule. So as x is equal to 0, t is equal to 0. X is equal to 1, t is equal to 1. Therefore, by method of substitution, I become that is half dt t plus 1 and 2 plus t. So by method of substitution, we get this form. This was the one rule we use here. Now, if you see here we have to use method of partial fraction. So take it as name 1 and take 1 upon t plus 1 into 2 plus t is equivalent to a over t plus 1 plus b over 2 plus t. So to get the value of a, put t plus 1 is equal to 0, that is t is equal to minus 1. Therefore, value of a is equal to 1 over minus 1 plus 2, that is 1 over 1. We substitute t is equal to minus 1 in 1 over 2 plus t, as we are familiar with this method. So a is equal to 1. Now to get b, put 2 plus t is equal to 0. That gives t is equal to minus 2. Therefore b is equal to 1 over 1 plus t. 1 minus 2, that is minus 1. Therefore b is equal to minus 1. Hence I is equal to, that is half of integral a over 1 over t plus 1 dt, that is ranging from 0 to 1, and minus half over dt 2 plus t, that is ranging from 0 to 1. So in this we get these two integral which is equal to I. So this is very easy to calculate the integral of 1 over t plus 2, t plus 1 or 1 over 2 plus t. It becomes log of t plus 1 ranging from 0 to 1 and half log of t plus 2 ranging from 0 to 1. This range is lying from all the log function, not only for t plus 1. Half is common out, so it becomes log t plus 1, that is 2 minus log of 1 minus half is common, log of 3 minus log of 2. That is by the fundamental principle of integration. Half is common out, we get log 2 minus log 1 minus log 3 plus log 2. So we get half 2 times log 2 minus log 1 plus log 3. So here we get half log m raised to power n log m raised to power n, 2 raised to power 2 minus log m plus n log 1 into 3. That is, we get I is equal to half log 4 minus log 3. That is half log m minus n log 4 over 3. So that is our integral of x dx over x square plus 1 into x square plus 2. Now the next problem is, that is problem number 3rd. Evaluate 0 to 2 pi sin ax into sin bx dx for a comma b belongs to natural number and a is not equal to b. So let I is equal to 0 to 2 pi sin ax into sin bx dx. So we multiply and divide by 2, that is half 2 times sin of ax into sin of bx over the variable x, that is varying from 0 to 2 pi. So it becomes half of 0 to 2 pi cos c minus d x minus cos c plus d x over the variable x, that is 2 sin c sin d, that is cos c minus d minus cos c plus d. So we get half integration of cos is sin a minus bx over the differentiation of a minus bx is a minus b, that is varying from 0 to 2 pi. minus sine of a plus b x over differentiation of a plus bx is a plus b. Range is 0 to 2 pi. So we get half 1 over a minus b is common. We get sine a minus b 2 pi minus sine 0 minus of 1 over a plus b common out, sine of a plus b 2 pi minus sine 0. That is by fundamental principle of definite integral. That is half 1 over a minus b, as we know that sine 2 pi is 0, 0 minus 0 minus a plus b, that is also 0 minus 0. So we get half of 0 is equal to 0. So the integral of given problem is 0 by using integration by parts for definite integral. So next problem is evaluate integration from minus 1 to 3 modulus of 2x minus 1 dx. As we know that mod x is equal to positive x if x is greater than 0 and is equal to negative x if x is less than 0. So we will use this rule while solving this problem. So let I is equal to integral minus 1 to 3 mod of 2x minus 1 dx. So first we will take and use this above rule. Mod of 2x minus 1 is equal to 2x minus 1 if 2x minus 1 is greater than equal to 0. That is, x is greater than equal to half and it is equal to minus of 2x minus 1 if 2x minus 1 is less than 0. That is, x is less than half. So we have 2, that is a partition, that is minus 1 to half and half to 3. So I is equal to minus 1 to half, and in this form it becomes negative of 2x minus 1, and from half to 3 its value is positive, that is 2x minus 1 dx as stated above. Now the problem is very simple. We can do it. Minus is taken out. We get 2 x square over 2 minus x, that is the integration ranging from minus 1 to half, plus 2 into x square over 2 minus x, integration ranging from half to 3. So we get that is minus is common out, x square minus x ranging from minus 1 to half plus x square minus x ranging from half to 3. Therefore, by using the fundamental principle of definite integration, we get I is equal to x minus x square ranging from, if we take out minus inside, we will get x minus x square ranging from minus 1 to half plus x square minus x ranging from half to 3. So we'll use fundamental principle of definite integral. It becomes 1 over 2 minus 1 over 4 minus of minus 1, that is minus 1. X square minus 1 is 1, so it is 1 and it is minus 1. Plus value of 3, that is x square, that is t square is 9, minus 3, yes, minus 3, then minus lower limit, half square is 1 by 4 and minus half. So here we are substituting right. Now half minus 1 by 4 is 1 by 4, minus of minus 2, that is plus 2, plus 6 minus 1 by 4 minus 1, that is minus 1 by 4. So we get here 1 by 4 plus 2 plus 6 plus 1 by 4. That is 8 plus 2 times 1 by 4. That is 8 plus half. That is by taking the LCM 17 by 2. So we get the value of integral, that is 17 by 2. So here we use the one rule of integration, that is a to b fx dx is equal to a to c f of x dx plus c to b f of x dx. That is the working rule for definite integration.